Section 7.4, Multiplication and Division of Radical Expressions. When we multiply and divide radical expressions, we must have the same index, but we do not need the same radicand. We simply multiply the radicands together. So, square root of 8n to the third times square root 3n. We take 8 times 3, which is 24, and n to the third times n to the first is n to the fourth. Now we can factor the 24 so that one of the factors is a perfect square, and n to the fourth is already a perfect square. Factors of 24 that give us a perfect square factor would be 4 times 6. The square root of 4 is 2, so we pull that out. The square root of n to the fourth is n to the second, leaving only the 6 underneath the radical sign. Final answer, 2n squared times square root 6. Another example, square root 7 plus square root 3 times square root 7 minus square root 3. We are going to FOIL this. Square root 7 times square root 7. Remember, that is the same as squaring a square root, which is just the radicand, 7. Square root 7 times negative square root 3 is negative square root 21. Positive 3 times, or positive square root 3 times square root 7 is a positive square root 21. And square root 3 times negative square root 3, again, is like squaring a square root, which is just 3. Now we combine our like terms. 7 minus 3 is 4. And square root 21 plus square root 21 cancels out. Final answer is 4. To divide radicals, we look and see, are the radicands divisible or reducible? In this case, they are. So we can rewrite that as 3 times a single square root of 50 over 2. Now we can divide or reduce 50 over 2, and that gives us 25. Square root of 25 is 5, so we now have 3 times 5. Which is 15. Another example of a cubed root with the fraction underneath the entire radical sign. We cannot reduce 5 and 8, but we can go the other way and split this into the cubed root of 5x to the fourth over the cubed root of 8. In the numerator, we cannot take the cubed root of 5, so that is going to stay underneath the radical sign. And x to the fourth is not a perfect cube, but we can factor that to x to the third power times x to the first power. X to the third power is a perfect cube. In the denominator, 8 is a perfect cube. The cubed root of 8 is 2. Now we want to take the cubed root of x to the third, which is just x, and that comes outside the radical sign, leaving the 5 and an x underneath the radical sign all over the denominator of 2. Rationalize denominators. It is improper form to have a radical sign in a denominator. It's okay if it's in the numerator, but not in the denominator. So to rationalize the denominator, we multiply it by itself. That's the same as squaring the square root. But anytime we multiply a denominator, we must also multiply the numerator by the same thing. So that gives us 2 times square root of 3 all over 3. Sometimes our denominators will have 2 radicals in it. In this case, to rationalize the denominator, we must multiply that denominator by its conjugate, which means the same terms with the opposite sign. That way, when we FOIL, the middle terms will cancel out. But remember to also multiply your numerator by the same thing. So in our numerator, we are going to multiply the x to both terms, and that gives us x square root y minus x square root z all over the denominator. And the denominator we are going to FOIL. Square root y times square root y is y. Square root y times negative square root z is negative square root y z. Square root z times square root y is a positive square root y z. And square root z times negative square root z is negative z. Now we can combine our like terms. Negative square root yz plus square root yz cancels out, leaving us with x square root y minus x square root z all over y minus z.